your screen. You are sharing.
Go ahead and share. Okay. Patrick, can you hear us?
Yep.
Sweet. Alright, so Redux Sagas, let's dive into it. First, I want to show you the little sample code that I made for this, because I think kind of leveraging the knowledge that Daniel Cox presented to us, like how to deal with heavy, complex things. I feel like first you should look at the code. I'll go over through my presentation and then go back to my code, so that way you have a better kind of, you have a chance to play around with it. So if you go to this, to this URL, there's some directions on how to clone it and how to get it out. One thing that we'll have to do is to enter the JP API that, I had to comment down.
I was the guinea pig.
Let me
already
Slack it.
Yeah. But I'll go get my laptop anyway. Okay.
You've been working on this for 7 months?
No, it's a template that I use.
Okay.
No, it's not.
Dang.
Man, the expectation just skyrocketed.
So I'll show you. You can literally control find GFD _API _key in the project to find exactly when you need to replace it. And let me know when you guys are always kind of in that step. Let me share it and you guys see why. So in UXUI, you'll find the key. And then I'll show you where it is. So you just go to package.json, and then on this line start, we'll just put this environmental variable in there. We just it's propagated to the front end once. I'm sure there are better ways to do this, but I didn't really spend too much time figuring that out today.
So the API key is anything?
Excuse me?
Your API key.
Yes.
Sent out.
Yeah, yeah, select it out in UXUI. So once you get the key in, you should be able to do npm start, and then you can navigate to a little host screen down or something. And once you do, you should see. You should see this. And then you press it. The first one.
Oh, it's random? Okay.
Yeah.
I got Lisa Bonet biting lip gif.
Oh, okay. That's good.
How appropriate. Cosby Show.
Oh, man. So this is what it does. It just randomizes pulls GIFs from JP API, but really what I want to display, the Saga is great for managing side effects, and I guess in this example the side effect is API request. I'll go over more detail what that all means, but here this example is really supposed to demonstrate how you can have multiple API calls in a row without having to do like .then chaining of your requests. So it should avoid you a lot of headache in terms of managing how these API requests return in terms of its synchronization. So now that you see the front end, let's look at what the code actually looks like. So the most important thing here is to navigate within the app. You want to navigate to containers, and within there, where everything happens is homepage. Pull it up right here. So yeah. And I guess the big reason why I really like the way Saga and Redux work together is because of this unidirectional flow of data. Everything is stored within the store, and that's a single source of truth. So if you look in the index.js within your home container, there you will find the button that triggers everything. You can do control find for press me to find exactly where that's triggered, and you will see a function that basically onClick function, which is a prop, and that Once you click it, the prop dispatches an action. At that point, you can navigate to the action.js folder within the container. And that's kind of the beauty of this flow. All your actions, anything that's interactive, is stored within the actions.js file. So once you trigger that action, that depends on the constants. They're defined in, once again, a separate area called constants.js. Through that mechanism, it can interact either with sagas or reducers. And in this case, we interact with sagas. So now let's navigate to saga.js file. The reason I'm going to go over this really fast the first time because that's our introduction. Then we'll go through the presentation and then we'll come back to this. And hopefully once you got a little introduction here and there, you'll get like a better handle on everything's going on. So saga is where all the magic happens. You'll see the main function called getJiffy that gets triggered by code below it. We'll come back to that too. But basically, all the magic happens within the getJiffy block. You see two of the separate API calls with call request and then a certain URL is passed to it. And you can see there's two of them basically to show you there side by side. And once the call is resolved, at the end of that try block, you'll see yield put change Jiffy source. And that's where we use a dispatch another action in the step 5 right here. Or sorry, in step 4, we dispatch another action. And then in this turn, this action interacts with our reducer. So this is mostly Redux stuff, but I'm kind of showing you how sagas fit into the Redux process, or like the pipeline we look at. And then through the reducer interacts with our store. At that point, once the store is updated, all our front-end components use selectors to sense how the store is updated. And the beauty of it is this process, it's kind of overwhelming the first time you see it, but after that, literally every single time you have any kind of side effect, API call, updates to cache, any interaction with your database, it always follows the same pattern. It always, actions are triggered, either sagas or reducers interact with the store, and then everything listens to the store. So every time, only updates to the store propagate to the front end. So that way you can always expect your components not to change unless store changes. And it becomes really easy to work with these requests because you never have to, every time a generator within a saga is activated, it's almost like a separate thread. Execution of the program is not dependent on the execution of the saga. And once the saga is done, the store is updated asynchronously. All right, so now that we'll speed run, let's actually dive into it. So what is Redux Sagas? And the official definition is that it's a library that helps you deal with these side effects. So what are the side effects that I keep hearing about? And it's a little bit misleading. They're not really a bad thing. They're just things that have to happen as part of your, things that you do with your app. And some of the examples are, changing values in external variables, API calls, assessing browser cache, things like that. Really good hands-on example using DOS. So this is a synchronous process that has no side effects. Your controller basically says, let's display a picture, and then he displays that picture. Very straightforward, nothing happens kind of outside that process because your image is already hard-coded, maybe it's a URL that's already in your system. But what if this image is fetched from somewhere else where you have an API call? So the API call in this scenario is a side effect of you trying to display an image. And usually it happens asynchronously. You have to wait until the information is returned from your API call before you can actually display that image. And that sometimes causes a lot of problems. So when should you use Redux Saga? Usually it's not appropriate for smaller projects. There you can probably manage using other libraries or just usual HTTP requests. But it's probably appropriate when you expect your application to grow to the point where there are multiple codependent API calls, or you just have lots of layering, or you just expect it to be really large. The beauty, as I kind of showed you in the beginning, what I really love about the structure is that even though it's a little bit more verbose, you have a very clear way to organize all your actions, and they clearly correspond to all your kind of interactions with the store through the reducer. And then sagas fit in the middle somewhere in there to kind of store all your business logic. So that's one of the big benefits, and let me go farther to describe kind of what is the state of the landscape right now. So obviously, we can already handle a lot of these API calls, just, let's say within the life cycles, they're present within the React. But there's some downsides. The pros obviously is intuitive, no additional libraries, but the cons is that oftentimes that means marrying your business logic with your component, reducing your ability to, reuse in other places, your ability to test them cleanly, your ability to basically have like multiple calls at the same time, because then you have to create these long .then chains or come up with like different ways to manage kind of like how your data is returned, how you're going to process it before you pass it on to the next call. Usually that blows up your component to the point where it becomes huge, and just makes it harder to obviously for people to get online with it and understand how to test them well. Anyways. So here's the usual process in that when we use lifecycle components or lifecycle functions to get API calls. At this point, another downside is that your component has to be stateful. It's going to have its own state, and if you use any like libraries such as Redux, it's actually going against the pattern where you're not supposed to be. You try to avoid as much as possible the state for containers. I mean, smaller components can have their own state, but it's preferably it's better to kind of reserve all of the store state management to the store itself. So what's the other alternative other than just using what React provides you with? Well, another common solution is using Redux Stunk. And here we're kind of inching closer to what the Sagas provide. Here you already have a much more integrated way to interact with the store and leverage a lot of these Redux provided actions and dispatchers and kind of interact with the reducer. So it kind of gets us there. For the downside of Stunk is that you still have to have these chains where you have to create promises and wait for them to resolve before moving on kind of to the next step using .then. And that kind of reduces our code readability and worst of all makes it harder to test. But to me it's callback chains, that's kind of the bane of my living, because I'd like to be able to fetch some data, process it wherever I want it, and use it to potentially go for another call. So here, as you can see with this process, we're already getting a little bit closer to what the tester app showed you in the beginning, where here we are using actions to interact with our store, and then the components update from the updates to the store. But there, once again, the downside is that you still need to chain them. So now we can try using Redux Sagas. So in this example, I think it'll probably be more valuable if I go over some of these keywords also as we go along with presentation. So as you can see in this code snippet, each function has an asterisk next to it. And that's a feature of ES6 called the generator. It's a generator function which actually returns an iterator. An iterator steps are controlled by yield keyword. Basically, the next step in the iterator is not kicked in until something is returned through the yield. And Saga, certain features of the Saga API help us manage this yield structure. So, for example, you can see here in this example, after yield, we use a Saga API function called call, which will evoke some kind of function of a pass to it. Once that function is resolved, instead of having generator.next, which is a normal way to move the iterator along to the next step, the Saga API will handle all of that under the hood for us. So that way you have much cleaner looking code where once your call is complete, yield is resolved, and you can move on to the next line. So in this example, once the first call is complete, we go to the next API call represented here by dogs with toys. And usually what I use is I just call that the response, and then you can console log the response and see exactly what's part of that data package. And another big benefit of this is because it's so granular, it's really easy to write these try-catch statements. So then there's a lot less potential for if your request is not resolved, you have a very clear error, and you know exactly what step that error is returned. Because in that then, there's a potential for these errors to be swallowed. So a couple of things to know about sagas. So Saga is these generator functions, as I mentioned when we were kind of skimming over my code, they have a unique triggering mechanism. They have, there's two helpers that are provided by the API, which is take latest and take every. So basically what we do is you have an action in your program. So for example, in our program that will return to this, you have once you click, there's one action that doesn't actually carry any payload. All it does, it has its type that returns, its action type. Our Saga watches for that type to be triggered, and then in this example, that type is fetch dogs are requested. At this point, it triggers the actual Saga fetch dogs. I'll connect all of this within our example app. This is kind of just I guess the big takeaway here is that there needs to be a trigger to initiate the Saga. And then once the Saga starts, there are different ways to, it's managed based on which of the functions you use to trigger it. Take latest, for example. It means that once you press the button, let's say you press it 3 or 4 times, only the last press will register, and all previous Saga spawn will get canceled. Because Sagas, as I said, it's almost like a different thread of its own. So these generators stay online and keep working like parallel to the process of your main app. So you want to make sure there's a way for these Sagas to stop being ran. Otherwise, they can swallow up more resources of your system. So I use take latest most often because it's the use scenario where I just take the latest API call return to me. Take every on the other hand, is more like a counter. You're going to keep pressing it and you want it to register each counter click, even if the next click is pressed while the previous click has not resolved yet. You basically build a stack of these generators for you to resolve. So that's kind of the triggering mechanism. So that's kind of going over back to the structure or data flow that I presented in the beginning, where the click dispatches an action. The action then triggers a watcher within our Saga, and that's like the trigger for the actual Saga to begin. Then the Saga, the generator, I use Saga generator, I will use interchangeably because it's pretty much the same thing, at least the way it's implemented. Then the Saga, the generator keeps working and doing whatever it needs to do until it gets the information back, and then with the information, dispatches an action to the reducer, and the reducer puts it to store for us. And once again, any changes to the store are sensed by our front end and show the data on the front end. And the beauty of it is just like this process is so robust. It's pretty much like it has all the features you want for pretty much any call you want to make ever. So you never have to deviate from this process once you learn it. You pretty much, I so far have not encountered any other, any time that you kind of like adjust it. It's unidirectional flow of data. And it's very predictable, basically. It's super functional because literally none of your components now have to have business logic because it's going to be separate in Sagas, and none of them are going to be, and all of them are going to depend on the store. None of your components will have to have their own state, unless it's something like a toggle switch or something like that where you want it. It doesn't matter if the main store actually has this business data for you. So let's talk about Saga effects a little bit. Those are those helper keywords that you have after yield. So you do yield, and then let's say you do call. And it's very straightforward, calls whatever function you give it. All is a really good one. Let's say, for example, you do multiple concurrent API calls. You could literally have an array of these functions and within the all function, and the Saga will not continue forward until all of them are resolved. So it's kind of like call, but when you want to have multiple calls together. So the other ones I use very often is split and select, because split dispatches these actions at the end of the Saga to actually write to my store. And let's say I needed some information to initiate my call that I store within the store. Before I initiate the Saga, I would use select to get it inside my Saga. So select is kind of the way Saga interacts with our selectors and thus the store itself. And these are, I haven't actually personally had to use these before because I haven't had anywhere where I needed to have an API with a brace condition or had to really manage my API call threads individually, but just for kind of general enrichment, I wanted to show that there's much more to this API that I present in this example, and it goes a little bit farther than that.
So quick question, does spawn, so when you're in your saga, you spawn, will it still assign a value to the left-hand side of that expression, in which case it will continue with evaluating the rest of your statements?
So I think
And
spawn
then later will return?
Yeah, exactly. So I think spawn is, as it says, is just a detached thread where it won't be like related back to the parent process that spawned it, that initiated it. I don't really know in terms of practice how it actually plays out because I haven't had to use it, but that's my understanding from basically like reading the API documentation on it.
When you say detached thread,
Yeah.
does that mean a web worker?
I don't think it has to do with the web worker. I think it's just how the internals of like the Saga API work themselves, as far as I understand.
Okay, so it's still on the main thread in the call stack.
Yes.
Okay.
It's not like a completely separate process, but I think you can keep executing apart from like any other execution that you have within like your other components.
Mm-hmm.
Is that a way to like chain sagas?
That's a good question. Let me think about this. So you want to start a saga and then you want to execute another saga once that saga is complete.
Or like sagas that don't necessarily need to happen sequentially, but can like happen at any time in the app. Maybe you want to do that?
They can happen concurrently and in parallel. Yes, absolutely. You could like those like take latest and take Capri are ways to trigger them, and you can definitely trigger multiple sagas like concurrently if you have some kind of action to trigger both of them at the same time. You can do that. Yes. So testing sagas. It's because of this generator feature of them. At every step of the iterator, you actually return an object. So you could use the built-in functions of iterators where you have this .next term to actually pause the saga at each step of it, basically at each yield statement. And at that point, you'll get a return of the object that that it's handling at that particular step, and you can compare it to some output. In this case, we'll compare it to, let's say, the first API call of fetch dog. So there, you just make sure that you structured your saga the right way, where after the first yield, you actually get the return of the API call when you have multiple API calls chained together. So that's a lot simpler to test than a lot of other alternatives, like with Dunk. You actually have to kind of like separate out. I don't have an example on this one, but trust me, it's harder. Anyways, I know I put a slide for questions, but I think right now it's probably beneficial to dive back into the code, just to walk through one more time, kind of the sequential flow that we see present there. So let's start off at index. To me, logically, it just, let's kind of walk down the same path where we had the button click. So we have press me button. So if you can see on click, we have a prop. By the way, notice this is an absolutely stateless component. It doesn't have internal state or anything like that. All the information it gets will be passed to it through props. So here we have on click random.
Which file are we in?
In homepage index.
Okay.
And so here are two important pieces. We can look at homepage prop types. And you can see how there's three props to this page. We have Jiffy source, which is the URL that Jiffy API returns to us. Then we have Jiffy keyword, which is the keyword that gets displayed above the GIF. And then onClick randomize, which is the actual function that kicks off the process. Mm-hmm. So the function we have defined in map dispatch of props. And there you can see we have a dispatch that dispatches and the dispatch is a Redux helper that dispatches load Jiffy action. So let's just follow the flow. So we dispatch load Jiffy, then you can command click and load Jiffy, and it takes us to the action.js. Yeah, here we go. So now we're in the actions folder, and the template I use actually provides you very clear directions and notes above it. So if you ever have to come back to this template, there's a really good kind of step-by-step additional kind of breakdown of what is happening under the hood. So here, load Jiffy only returns a type, which is load Jiffy. Load Jiffy is a constant that's defined in a separate file of constants within the same folder. And then if we, for a second, deviate and look at constants folder, you can see there's only 3 very specific constants that are defined there, and actually corresponds to the prop and our index. Let's go back to actions and just focus on load Jiffy. So now, once load Jiffy is activated, the type load Jiffy is returned, and that is changed, and that change is sensed within our Saga.js file. So let's navigate to Saga.js. So in Saga.js, if you scroll all the way to the bottom, we see this function that's called the root Saga. It's basically it keeps continuously running, sensing any changes to load Jiffy constant. And then we apply that function that's provided by the Saga API called takeLatest. And this is kind of the main trigger for the get Jiffy Saga that's written or defined at the top. So when we press the button, the load Jiffy constant is triggered to an action, and then get Jiffy function is activated. And this is where the main Saga begins. So at the top, you see our function definition, get Jiffy. Here we specify our API key and have the URL that we specify for our requests. And within the try block, first we call our random Jiffy URL, which returns to us. You see here, it looks very synchronous, like as if it's normal synchronous running code with no asynchronous parts or anything like that. And you see, I just assigned the keyword to the returned data from that API call. Then I use put, which is a Saga API function, to invoke another action. And this action is change the keyword. And I pass to it the keyword. This action interacts with our reducer. And in Redux, reducer is how you interact with your store. So let's take a little tangent from here and actually command click them to change Jiffy keyword. So once again, it takes us back to our action menu, or our actions file. And then we can, from here, to understand the connection, let's click into the reducer.js. So within reducer.js, at the bottom, you see a reducer defined that senses any changes to the constant. You see the constant is constants is the way you connect all of these pieces together. So once change Jiffy source constant is triggered, and it knows that the action carries a piece of information with it, which is the URL. It actually returns the state and sets the, it overwrites the initial state with whatever the piece of information is carried under that action.url. So at that point, we updated our state. Let's go back to Sagas and see how the second API call is conducted. So here we just took that random keyword, and I could have done it a few different ways, but because of just the simplicity's sake, I just coded in a keyword into the second part of the request. And once again, I conducted another call. The yield will wait first until the call is resolved, at which point, when the data is returned, I follow the same process where I use put Saga API function to record it through a specific action. So this way you can see every piece of data has a corresponding action, and then corresponding way reducer picks that action up. And while I feel like the first time we kind of go through it, it's kind of a little bit overwhelming, and there's a lot of specific new pieces. The first time I was kind of looking through all of Redux and Saga together, I thought it was, I didn't really understand why there's so many pieces to do something so simple like an API calls. But if you had to chain things like this, and for example, it grew to the point where you have a lot of interactions, and the app grew, it actually makes a lot of sense because, for example, currently I'm working on a GM data prototype, and I have a lot more containers with a lot of different, each container has a corresponding API calls. Now I have kind of, navigating the project is a lot easier because all I have to do is, once I get into the component, I immediately go to Saga to see, first of all, if it does have Saga, I know it's a component that's important because it makes API calls. And I can immediately scan all the API calls that are conducted there. Then I go to constants to really see what drives specifically that component. You immediately see the lay of the land to see all the moving pieces of that component. And another nice piece of it is that you immediately see all your piping. You see your actions, your constants, your entry point, and basically your store, what keeps your state, and you see what specifically is within your state. While your display components, using obviously styled components, are very nicely nested within the same file folder. And then you just have a much easier way to navigate and understand each specific container. And now I think questions.
My question and concern with this, if you have multiple components that each use different sagas, like how would you organize the structure? Like would it be similar to how we would organize Redux?
So for example, sometimes you have actions that are top level that apply to kind of, I think a great example is it's logging in. Let's say logging in is kind of a global saga type, or like a global event that propagates throughout the rest of the app. I would handle logging in sagas within the app, and then I would record to the app's reducer. So like global state would have my username and maybe login status. But then to make sure that we are logged in and we have the right username in the lower components, I would use the selectors from the app and then import them into whatever component needs to use it. So basically your question is, there is flexibility to import and export functions and actions between each component. So like for example, as I said, logging in mostly is a function of a global app. But if you need pieces of that process or data from that process, such as username, and you need it to propagate to other components, you don't do something like, in React before you had to pass props. None of that anymore ever happens. What you do is you simply import a selector from an app because you have these convenient ways to select slices of state or slices of store. Well, all you would have to do is you see how you literally would import this function from any component. It could be child, could be parent, could be triple child, could be triple parent, doesn't matter. As long as you specify the URL or like the path to this function within whatever component you have, you immediately have access to that slice of store that will also automatically update for you at any time. So that avoids that, nesting of props that you might have in like early versions of React that didn't have ability to use Redux.
So when I see kind of the dispatching of actions, I kind of think of like a state machine, sort of, and I'm wondering like if you're doing like, I guess, error handling, how would that kind of work with this? So
the pattern that I've seen most often used is basically, they get to it because it's running out of time. But basically, let's say you have an error. You basically create another action for that specific, corresponding to that specific piece of data that you're trying to fetch, code in the error, and through this action, you probably want to record it either to the store again and then evoke it in one way or another. But yeah, usually it's these try-catch statements that also use dispatch actions to record the errors themselves.
I kind of like how, since you've tied everything to actions, it seems like it'd be really easy to kind of mock out all the, I guess, API calls and stuff without actually hitting anything.
Without actually hitting anything. Well, the way I've seen the API calls tested, they actually try to hit them to make sure like the data, like the right data is returned. At least in that example with the dog that I showed you, they try to make sure the first step of the saga hits the call and they have like normal call without any kind of saga or anything like that, where they're actually testing like the structure of the saga being the right way. I'm trying to think of, is there a way to test it without making the call? I guess the benefit here of the testing is that you just have a lot more fine-grained control over each step of the call, rather than, because here I guess the comparison is versus Thunk is a big comparison library, and in Thunk you can't do that because you still have to chain them using .then. And then usually when you use .then, if there's an error in a deeply nested structure, it might get swallowed because the next call happens and overwrites any errors that happened in the previous step. And because Saga kind of lays it out, you can literally put try catch around every request itself. It becomes a lot easier to spot these errors if something's happening instead of kind of just like deciphering your whole chain. The use case scenario here is I'm trying just multiple API calls one after another. Because a lot of if it's just a single API call at a time, you might not need something as heavy as this.
I have a question.
Yeah.
Maybe you came across this in your research. I believe Saga's it integrates with Redux more purely.
Yeah.
Like don't Thunks you can get a promise or an object, but with Sagas you always get just an object back.
I agree with the second part. I don't know Thunk that well to really give you a good response on that. I never used it, but yes, always returns objects.
Okay, yeah, that's what I remember reading. Yeah, and that makes it definitely easier to test because you don't have to or even work with because you always consistently just have pure objects.
Yeah, exactly. And like the testing that I've seen done for sagas is basically they test those iterator steps so that before you could test literally the result of every yield statement. So you could pause this function at every single yield statement and make sure whatever is returned in that yield is what you expect it to return. So you have like a much more tight goodness over. But to me, the big benefit, I haven't even done too much testing with the structure. To me, the biggest thing is that the file architecture of every component now. First of all, every component is stateless, beautiful. And no stores always has what I need. That gives you a lot of functionality just because of selectors and actions. Actions always have to do with any changes. Selectors always select slices of the store that are applicable to that component. So if I have siblings that need to interact with each other, I could just keep importing selectors from one to another, and then they can use selectors within a component to select slices of whatever store component they want. Without ever having nested structure. Everything is very flat. Everything is parallel. Pretty much every component is a sibling, effectively, in terms of data, in terms of passing data from one to another. There's never any need for a nested way of passing data down.
Did that answer your question?
Oh yeah, my question was answered.
Yeah.
Okay, a while ago.
Yeah, this was like
that was a tangent, but thank you.
Yeah, sure.
I've got another one. So in constants,
Yes.
I was noticing that the values there were kind of interesting, and I was wondering what those, if you're namespacing or how that kind of works.
Yeah, so from as far as I understand, this could be anything. You don't even have to define it. This is just an internal plumbing for the way Redux works. And the more specific this is, the less likely you'll have any kind of collisions between constants. So the idea is that because of this kind of URL namespace structure, let's say the next component will have a different name. So here I have actually home page, which I should have wrote, but it's actually, so the next component will be I don't know, API page. I would press API, I would write API page and whatever constant name. And the idea is that when the reducers or sagas become this constant, you just basically have less potential for the collision between different actions. And it makes it just much more certain that every time you trigger something, it's not going to overrun. And it really becomes a concern, not in small apps like this, but let's say when you have, every component, you have 100 components, and each one has 10 actions. And then maybe like 2 of them are like get username. So get username within, API action could be different within login or something like that. It just provides you that ability to be more precise with what your custom naming convention is.
Kind of makes me think of like BEM or something for CSS, even though that's totally different. But
oh, just the way it's written.
I mean, I guess it's just a global thing, and you're namespacing it.
Gotcha.
To prevent collisions.
Yeah. Okay. But yeah. Well, then the functionality or the reason for it is exactly the same. It's to prevent collisions. But I guess the best, like when I started working with React, my personal experience was I didn't have Redux. I think it wasn't even out yet. And the issue that I ran into was I would have to keep passing data from like, let's say my app component, like 4 components in as prompts. And then I realized, well, how do I actually get it? Like if there's any API call at the deepest level, how do I pass it back to my app? And then I would have to have functions that would like pass it back up, or like trickle it back up. And this completely solves that issue because now virtually everything is a sibling of each other through the use of actions and selectors. So I guess it's also advertises for how great Redux is. Great, because like Redux is definitely the biggest advantage of this, but Saga is like the piece of that helps you have that unidirectional flow where API calls become separate. Once they're done, they go back to store, and then the store updates all of your front end.
Yeah, I got a question.
Yeah.
Can you guys hear me? So for the API calls, you don't need to use Axios or anything. There's no allowability with Sagas, right?
I don't need to use Axios for what?
The API calls.
Mm-hmm.
There's a call function.
Yes. Yeah, so call function calls just any function you pass to it. And here what actually is done, we have this request helper, and request helper simply uses fetch API to do a normal fetch. I think request here just obstructs, give me 1 second, yeah, request. Here the fetch is literally, or request is literally this. It's a normal fetch API fetch that you use with just some additional contents to process the information that's returned to you. So no, you don't have to use Exif or anything like that. This is fetches the normal XML HTTP request wrap.
And this is something you get from React boilerplate fetch and this utils thing?
No, this utils was specified or like written by the template that I used for this mini project, which was a React boilerplate template, which I just scaled down and made sure we had 1 component, so it's really easy to notice all of the things that are happening with this like really small sandbox. But yeah. Because I would honestly just use fetch, but they already had it, so I might as well. Does that answer your question?
Yeah, after showing me the code, yeah, thanks.
Okay, great. Yeah. Of course. And that's pretty much it. And honestly, if you have any questions, and I hope you try to make use of it. I think this is as simply as you could kind of boil it down in terms of like the structure. But yeah, just because it's so flat, it's really easy to kind of work at once you kind of get used to it. Because in the beginning it was like I really couldn't, like the sequence of working, dispatching actions, and then how, like kind of like where do they go? Because I can't do command click onto the function to really trace it down. But the glue is really the bold constants that connect everything together in the back end.
Cool.
And mandatory touchdown.
It's fucking heavies.
Yep.
Very cool.
Yeah, there we go.
Yeah, it's cool. Like when you click on press me, you can see the text row at first.
Yes,
And then it makes a call
then,
to get it actually flows with the way the Saga flows.
exactly.
You'll see the text render in the UI, and then it makes the call to get the GIF, and then it
Exactly.
plays it. So
And you can exactly see exactly what
the
happens.
UI is actually visualizing your Saga in a way.
That was, I'm not gonna lie, that was kind of part of what I was thinking as I was going with it.
Cool.
Okay, I can't stop the recording.
On your touch bar, do you have to stop?
I do, but it's not giving me the.
If you leave the meeting, it'll just stop recording, and you'll still get your